Okay, so I am going with some example now. That will also make it clear. So this is the example. So that slope is 1 is to 3. Now they want to revise it to the addition to it with 1 is to 1.5. And now suppose I am putting different factor of safety. So now this is one somebody like when we say conjugate gradient, that time it is one of the sorts method. Like we are talking about, one is the stability method, other is the sorts method. So that's why I wanted to, that also I have considered this conjugate gradient is a sorts method. Also Monte Carlo, pattern sorts, all these are sorts method. Hello. So then also we can use finite element method. So you see the factor of safety, it is a fail slope. So the factor of safety may vary from 0.405 0.41. So it is a failed slope. It was found that it has failed, then it was analyzed during method, so found that it is failing. This is one. Now then, this is what we are talking about, failure surface. How is the failure surface is? So this, you see, if you are saying plaxis, you see this is a plaxis, a band is showing. This is showing a band through which it is failing. And suppose say Monte Carlo is showing, it is showing failing like this way. And this is a conjugate, another method. It is showing that it fails this way. And other is failing like this way. So different method may show different failure planes, so that's why the values are different. So this is also important. So like here, David and Fletcher Powell, this is also another source method. So that way we analyze. So now you will see factor of safety, yes, that was a failed slope. Now here is just 1. So factor of safety 1, 0.0, 1.00, 0.987. So this is critical. Even there also, when we plaxis, it is a finite method. It will not only give you factor of safety, also stress, strain and settlement. Then, because actually it should have been stress, strain and settlement. But obviously we are accustomed with factor of safety, so they have put this model. That you use our software also, you will get factor of safety. Truly speaking, it would have been given stress strain because finite based. But to follow that previous pattern, who is following that slope stability means we need a factor of safety, they have also put this criteria with certain condition that where this resistance by disturbance by resistance, how much it is, accordingly they have calculated. So you see, failure pattern, plaxis shows is here, a band like this one. Dividend says here, and method of slice says, I mean that another with the pattern only random search, it is showing different. So this makes a difference of a different factor set. So this is with a liner. Suppose then if I do it, now comes to this is also what important point I want to tell you. I am using plaxis or I am using geoslope. In geoslope we don't have much to give, C value, phi value, gamma value, pore water pressure. Okay. But if you will go for plaxis, it will ask you what is the Young's modulus, what is the Poisson's ratio, and then C, gamma, phi, it is already there. So when it comes to find out Poisson's ratio and modulus, in geotechnical engineering we fail. अरे soil का modulus कहाँ पता है? मतलब most of the time we are not aware about it also. Soil also can have a modulus. But if you are going for plaxis, you need to put this. So that's why I said parameter. The software will ask this parameter, you have to give it. So you have to see how to find out these parameters. So now even the geophysical method is also correlated with Young's modulus and Poisson's ratio. So if you are going for advanced numerical methods, you have to put also advanced. Even they will ask for angle of dilation. That also this plaxis will add. So this angle of dilation, if it is not there, somebody people is 5 minus 30, 15 degree, 30 minus 15 degree. I mean, random. So then comes many times empirical method. So as I go advanced method also, I need to find out some more parameters. So this is nowadays available, but you have to do those tests. Okay. So This is using different software. I don't forget, don't go for this one because there are different techniques. And you see the values are also different. The point of idea was that I'll just apprise you that because these are the people who have already solved this same slope and we are trying to solve it. So somewhere using, they got 1 point here also, we got 1, somebody get 1.17, somebody get 1.25 and so on. Suppose a Bishop's method, give 1.25, but actually it's 1.1. So Bishop's method, so that is the variation of 10 to 20% variation is there if you compare to with a numerical method like a Plaxis method. So here that is again, so different maybe because you see Plaxis was just trying to follow the path where there is that layer. So obviously I will try to see that means okay which is giving the reasonable. There is a chance that this may make a reasonable vulnerable zone for sliding. So that is what Dr. Ponda said that you have to see this also the sloping sliding zone. Where it is sliding, is it an appropriate sliding zone or just giving some values? Because today I will also go and put a slope like this, I will also get a factor of safety. Okay. So now, so this way you can do it. I am just trying to show one model. Because if you go with the limit equilibrium method, like here we are talking about a case, if you will see the closely, this photo is 2011. So that time actually there was some mining company said that we want to, that time the fly ash they were mixing with overburden and putting it. So they said it was only 8%, they said that can you go with the more than that, 25%, up to 30% like that. So that time we did this study in Raigad. So then we collected some sample and and did it in the laboratory. I am not going with the details of the test. Then the problem was that it's not only they will mix it and dump it, they also said, can you put some layers in between? In between the, and if you see, this is there in. Suppose like overburden in between the fly ash layer, only fly ash. Or fly ash with dump. Overburden.
Mixing is the best.
Yes.
I can tell you mixing is the best. You can do that. But how much percentage again we will do some test and trial and error and so far like in my own experience I have never used anything more than 6%. I have used that again in the road like for our software. Software I use like 6% down. But when we put the layer in the slope, that's a completely different because we are creating the weak zones. Like I am saying, if you put the fly ash, it's the weak zones. But again, it varies from site to site in that particular site, what kind of, because this fly ash is not same everywhere, it can change also.
Yes, it can change from plant to plant.
Plant to plant, and so you again, the people who are doing that, they should have their lab data and then prove it, and then also after deposit, like making the thing, also you collect the data and then see.
You have to monitor. So actually this fact is also same thing, exactly that is what I want to say. We did this one with the mining engineer, I was a gentleman. So this way, we tried different trials. Then we said, this is how we can make it. We did it, but after everything is done, DGMS also approved factor of safety and so 1.39. They said, oh, it is factor 1.39. Then came, that time also environmental was not that important. We did it in 2011. Then immediately say that seepage will come, water will go out, fly ash is hazardous, that time fly was hazardous still. So then they said to monitor it. The problem is then we started, so he started monitoring, I left that, so I came. So he started monitoring it. So the thing is that anything new in some of the standard, like British standard, I will tell you another example. So there also, because here you see, I model it. Plaxis, yeah, it can do any types of model. These are all three models we did in Plaxis. And then I found the factor of safety. And this, suppose it is showing only a typical type of a shallow failure on this surface. So, am I satisfied therein? No. Even if I get whatever the software or material is there, what he said is, Dr. Panda is correct. You have to monitor anything new, what you are doing to be monitored. In our, like if you go to American standard, it is there in any geotechnical exploration consists of 4 parts. Desktop, reconnaissance, detail and post construction. But here in India, we don't do any post construction. Ho gaya, bas. We never consider that if it is performing as per the design or not. So this also, then after somewhere, due to problem in construction, this fly ash came out, so this was rectified, but ultimately now this is being followed with certain modification. Initially when started 2011, so obviously what you feel, immediately what you are planning and executing, unless you monitor, it may not be a success story, and I mean it will be dying out also. But that is the need of that tower, because fly ash to be used, and this fly ash plant is close to the mine. So they have got both the combination. This is one example. So this is another example. This is what you are saying, this fly ash. They covered it with natural. So this is in another Chhattisgarh. So one day happened, there was a heavy rain, and this topsoil first started to move. And then after you see, when the topsoil moved out, they made a big trench. Fly ash became just like a fluid and flow like that with it. So if actually if you see another photo might be, you see nearby there was a agricultural land. So all it covered with this one. So then we went there to do this analysis. The most important point was the soil properties, because fly ash, this is also 2010 that time, same nearby Chhattisgarh. So that first what I wanted to study, because fly ash done it. So this is to be, this does not have any cohesion, and the friction what you are assuming, it is also a transient phenomena. If it sticks to it, or there is sufficient natural, load, specificity is less. So for that reason, if the water comes in, gone. Or even if it is a water dry up also, it is gone. It has no strength. There are two ways. So it has to be in that situation. So that we try to convince, and then we protected with a short term. We calculate how much should be depth. If it is there only, then we analyze that. Computer will do analysis. That is not a problem. But first you have to invest what you have to go for it. Like putting on the topsoil, in that topsoil on the core OB, they were not initially. So that's what, if you are going for plantation, I always, that time I said, minimum 1.5 2 meter of natural soil you have to give it. Because otherwise there is no plantation. Because anything comes below 2 meter, 3 meter, what is the nutrients? No nutrients, how it will grow? So for that nutrient you need natural soil. So then only it is possible. So that way, anyway, this is what we try to make it the toe wall, drain around, and then we rehabilitated and found that this should be the things, and then we abandoned. This is not a good idea. They are putting it on the land where there is no dike, no embankment, only there is a small pit, and above that they were covering with a 0.5 to 1 meter of topsoil. So this procedure is almost now closed. This is another case. So if you see here, this is an because stability, unless we are talking about, because this property of the tailing is very important to know. This is in Jharsuguda. Jharsuguda is one of the plant. The plant has got a flyover. In their own plant, the railway line was there is a flyover. Their own flyers. So they used it. And they did it using this wall. And the contractor was a big contractor. 1 or 2 rank in India, big contractor. So they followed it. There they analyze these things, everything. But what happened? Just in one dry season, the construction was going on. All these here it is started only. Other side it is just moved by point 0.3 meter, 0.4 meter that moved out. But when they show me the photograph, they didn't say that this is there. They simply say that this has happened, and there was no Indian standard. There is only British standard BS 8005 or so there. So if you can analyze, it will be convincing. So without looking at the site, I agreed. Okay, I'll do it. But by the time I reach, that is all, it is sliding out. Then I say that what is the analysis you have done? So that is the computer analysis. Computer analysis was around 300 pages. For the strip that geo strip they put it, and this fly ash analysis, laboratory showing was 5 value between the strip and the fly ash is around 32 degree or so. Accordingly they have designed 32 or 40 around degree, and they have designed it everything. So then I said, this is not acceptable. Now that we have to do all the analysis, I said, but can you tell me with a pull out, will that strength? Because the fly ash when they are dry, they have almost zero cohesion. And when you are saying this friction, fly ash are spherical, you see, how much they can bind themselves to give this friction. So finally, I simply, when I say blending, I say that you have to add at least 25% sand. So they said it will be go beyond our cost. Finally, with 15% sand, because blending, what Dr. Panda said, I always try to follow. Because I just give a fundamental principle that before coming to the plant, it was a resource. Getting to the plant, I mean that furnace or thermal converter is a resource. Once it comes out of it, it becomes a waste. So what has happened? Something it has been taken out from it. And so whatever it is left, if I can amend that value, blend that value, so that it will regain. So that is the logic. So that if it is something is missing in it, that is what we need to put it. So it is spherical. It has no angular particles, and my design of friction simply says that angular particles gives better friction. And my RE1, reinforced earthwork, for which you do stability analysis, again we do stability analysis, is based on the principle of friction. So that never that tear out. The strips you are now being designed, it is hardly breaks. But the most important point is the friction between the strip and this hoist. Now that's why what they are doing, if we are using with the fly ash, everything is covered and then RE1 inside. Because what they did the mistake here, they made it dry, no amendment, no covering. So there was no water to give some of the cohesion or friction to the fly ash. Between these two, it was not there, and it was lost just after. And you will see they are all, it is a big contractor, and they are not any lacking in the knowledge of using RE1. But the problem was understanding this, and these took almost 3-4 meetings with, because they read with computer analysis. Computer has given the factor of safety is more than 2 or so, for all sliding, overturning, bearing, everything is therein. But fundamentally they have forgotten that these material properties what they have taken is not the correct properties. So this can never, it may show you, but that may misguide you also, parents.
Is it a road project? Road
RE1, reinforced earthwork.
RE1, but it's a road construction, right?
Road construction. This is, then after also now with the fly ash, that way two in, this was in Odisha, another was in Angul also, to both have done with blending. But now here, another one they are doing it with covering. Because they are not using strip, they are also using this the net, I mean that what they call geotextiles nets and so. Geogrid synthetic, so they are using that one and doing the analysis. So these parameters, so that's why important point is not that what software you are using, important point is that first you have to, always you do, an engineer, that's why always first sit in the table and make a chart of all these things. What I am going to do, how to do it, which side it will be, so because everything, computer just assistive. Like a doctor only go with the testing to already what he has thought about to confirm it. So an engineer as a general he should have an idea about that, how should I go it. This computer will only help you to say that yes, what you are thinking is justified or technically correct, or what you can go with it. Okay, so I think, okay, this one, another example, small example in mind, I was saying. So you might have seen this type of those who are dealing with iron ore. Iron ore, this is all red, somewhere this white patch are there. And if you look at this, so it is failing. Slope, this is what we are talking about as slope, we are benching. And there are so many, so that is not a failure, you see. So this could be, all these benches in the white region, if you see, it was all failed. If you will do any analysis, so similarly it may fail. But this failure is for different reason. So this, soil whatever it is, called dispersive. Once the water comes in contact with it, it will disperse. I mean to make a hole and pass through. So this is not a slope failure. So this, you see, when I visited for some other purpose, but they suppose they say that, you see, this is what we are trying, it is failing. So this is not a matter of concern. So what you say, the slope failure is small, these are local failures. If you give the small strength, it will be stable. So computer will show that it is failure. So here you see, is it a problem in this case? As you are asking that local failure, this is a local failure. So no issue. Overall it's stable, but somewhere because that is a weak zone there, so that's why this slope has failed there. And during this happens, mostly in drainage region, water passes through this. So these are the aspects when we go for slope stability, we need to keep in mind this may happen, but that whether it is a matter of concern or not, that's the judgment of the engineer. Okay, thank you. If you have got any queries, then I'll be.
Sir, design of Redmond dikes.
Design of?
Dike of Redmond, parent dike. Some designers suggest liner on the upstream side. At the same time, they suggest sand chimney and sand blockade rock to drain and downstream side. For what purpose? If you don't allow water to enter into the dike, we invest for sand chimneys and drain.
Okay, so I didn't find any also reason why they have put it. So they want to keep the embankment dry. What reason? Suppose the embankment, because that is the idea is that the water can never enter the embankment because they are putting the line. So another issue is that that's why the only thing possible they can do to keep the embankment dry. If I put a drains in between, because that is what we call it also, like in suppose this room I want to drain it. So at different points I can put some drainage layers. So once this drainage layer comes, the soil water nearby it will pass through, and then it once reaches that there, it will go down. So then the staggering should be better done there instead of providing, I mean that could be one of the reason it may help the embankment. In the sense, let me draw this way. Suppose say now this is my embankment. So I am putting a drainage layer here.
Yes.
This is my upstream. So to keep it only the water, suppose a water particle is here, because this is impermeable.
Yes.
There. So only the water from here, if it reaches here, it will drain out. Otherwise, initially what was happening? This water has to travel to this distance to come out of the embankment. So that way it will help that this water is coming to this chimney or drainage layer, whatever you say it, and then once it reaches a distance, close distance, quickly it can reach here, and then it can pass through this out, go out. So that advantage you will get it for keeping the embankment dry. Nothing more than that.
Okay. If you put this impermeable layer upstream side, only the precipitation water,
Yes.
the rainfall water comes inside the tank. For that purpose only we are providing this.
Nothing else.
Direct rainfall.
That rainfall or precipitation or whatever it is coming on this embankment only. So that embankment, suppose if you want to keep it dry, it will be passing through because distance come ho jayega. So from here it will reach immediately the drainage layer and pass through. That's the advantage.
Yeah, and also what's your upstream slope?
1 is to 2.5.
2.5 to 1. And you don't have any issue in putting liner there.
So we are providing liner, no? But base and
Install.
dike slope.
When you install the liner along the upstream slope 2.5 to 1, you don't have any issue. They can easily put that. Contractor can easily put that.
Yes.
Okay.
They are now stitching with this.
Yeah, because like anything above
Three, yeah.
3 to 1 is kind of people. If it is steeper slope, you cannot put a liner there. Good installation will be difficult.
The liner length and width is 8 meter to 140 meter length. They just keep the bundle at it, so they just roll it to the bottom. And while stitching, while stitching they can easily stitch.
And nowadays, even thermal stitching is coming, so that's not a problem. But stitching to the soil, how they are doing it.
Stitching to the soil.
I mean, dab.
Just we excavate 1 meter depth at the top of the dike and put the liner to the strength and load it with soil or border at the top of the dike. And the bottom, the part is horizontal shoulder.
Your role is going from the top to the bottom.
To the bottom,
And you are anchoring on the top,
Anchoring.
anchoring on the bottom.
not getting the bottom.
Just leaving it.
Just leaving it.
So, and you just also leaving it along the slope.
Around the slope and below the base, to the base also, throughout the base, around the dike slope and base. There is a continuous liner we are providing. Only anchoring at the top of the
But again, you have to be attached to the slope also, no? Like just it stays like rolling. And there is no like the
Hey, it doesn't slide.
Above that they are putting some soil on it.
Soil. We make a trench of 1 meter depth and 1 meter width.
No, then
But
what
the
is,
soil
once
is
you spread it,
better, but-
suppose now you spread it here,
You-
then you cover it with the,
No, it is open, sir.
It is
Open now.
open. So that's what my point is. Like if it is open, then it is exposed to the atmosphere. Yeah, then the role of liner will not be that. Liner should not be exposed to the atmosphere. You see?
Till it means till it is full to the dike, funding is to the dike.
Again,
It will be exposed.
there will be rainfall, there will be lot of other things. You have to again monitor that liner constantly. Make sure that liner is good. Liner is good. And in our installation, we do lot of test also. After we install, we go and do the test. So along, that's why like normally we do not go anything steeper than 3 to 1 because on the slope you cannot go there. 3 to 3-to-1 slope putting there is difficult. You cannot do any test. So that one just you leave it. You just think that it is all good. You see, the material, you are using so much material and you cannot taste it once you put it there. Only you can taste on the top or little bit on the bottom.
When there is a
So
liner,
you have to assume that.
whenever there is a liner, crack in liner or puncture,
Yeah.
and the water coming inside dike, that will be drained out.
Yeah,
So that just to keep the dike dry, they have put that. Otherwise there is no use.
otherwise, no, it's exactly.
Some designers provides this vertical liner at the middle of the dike, cross section of dike.
Vertical liner.
Core.
liner.
Instead of core,
Instead
Acha,
of
we
okay.
are thinking a liner.
liner, they are putting
Yeah.
those.
But the problem is, again I can
Tell you, there will be a gap between the line, along the slope, there will be a gap between the liner and the slope. Definitely, no doubt in it.
At some locations it happens.
And if there will be a small hole in the liner, which is possible because we are keeping it open, anything can open it. When you keep it open, anything can happen. So, if there is a small hole, your whole concept of liner is gone now. You see, you are creating a zone where between the liner and the soil, there is a gap. All the water will go there. So now what you have created one. You have created one. So these kind of, again, like the objective is good, but you have to make sure that there is a tight, like it stays into the liner installed very far into the ground. That is one of the assumption of the liner is installed far into the ground. So that what it is protecting. But if there is a gap between that to that, and then so what you are doing. So that's why anything higher than steeper than 3-to-1 slope is very difficult to line it. Yeah.
Practically it is very difficult. Somewhere we
Mhm.
get to this gap.
And again, you are telling like you are putting vertical like yeah, so you are just leaving it there. Dropping it from the top and it goes to the bottom. That's all you are doing. In case of a vertical liner. You are not keeping it tight.
So, sir, what is the solution for anchoring that soil and the liner? You want to put some new hook on that?
Like again, when we put the liner, then makes sure liner stay there.
Is the contact between the liner and the soil should be...
Soil should be there. And somewhere, again, basically, these are like very thin liners, like the geomembranes. Even if there is a thin liner, but we do not want it to slip. Because once you put a liner along the slope, it is creating down to slip. If you are not putting it like a hardly on the surface, everything can slip away.
That is why we are providing the anchor trench at the crest of the...
At the crest of the liner, correct. That you should do that. But again, you are put in one place. But in the other places, it is fully loose. There is nothing to put into the ground. In the other places, normally we do not anchor it, but we make sure it is firm on the ground, like attached to the ground. Not that there is a loose, there is a gap between the liner and the soil.
So providing that U-hook is not a very good solution.
Which one?
At the slope, to anchor the liner with that soil, putting the U-hook, whatever we are putting
On those
on the
crest.
slope, yes,
Yeah.
not crest, at the slope.
On the slope again, like that's why I am saying, like when it is steeper than 3-to-1 slope, we don't have any option. Because normally when we put the liner, we go and check the liner, make sure it is firm to the ground. Like, we do not have to keep it very loose. But here, it will be always loose because you don't have any option. That's what I am saying.
So whether we anchor it or not, we can't keep it exposed, right? That's the main. Like we can't keep the liner exposed to the atmosphere.
again, like, if you hear, like, it is being exposed for a long time, because wherever we are putting a liner pond, but again it is fully water. Sometimes there will be no water, but in the long time we keep it open to be exposed to the atmosphere, which is all like dry, rain, and human lifetime is gone there.
Okay, thank you. It is a long discussion. So now we are already lunch time. So we stop here, and again we'll meet it in the here. Okay.
So after lunch, please gather back here, and I request you to please sit as per your group. So maybe 2 seats for one first group, then 2 seats for second group, like that.